If you haven't had your mind blown by the double slit experiment, then you haven't looked into the double slit experiment. I mean, originally done back in 1801, this experiment has been blowing minds since then. Quantum mechanics is just a mess because of it. All the YouTubers have covered it. Vsauce covered it, Veritasium, Joe Scott, all of them have gotten their minds blown by this. Recent experiments have shown that maybe we actually finally have an answer or even a hypothesis for what could be going on in the double slit experiment. And it really shakes all of science to its core, and I think they're not willing to look at it. I think this experiment could be the key to finding out what's going on, what is up with our messed up model of the universe. Why do we require so much crazy math in these ridiculous matrices that not even our most complicated computers can solve? It seems like we're just missing some really key point of information. And I go through it in this video, what I think that could possibly be very exciting. So we've been at the same spot for 80 years. Maybe we're looking at the problem in the wrong way. Thank you for being here. Smash that like button. If you do like this content, consider subscribing to get notifications on my future videos. I release a video every Friday. And then if you want behind the scenes access and additional bonus content such as live streams and live video chats as well as merch, go to patreon.com/Chris Lado. Now onto the video.
Experiment, so I'm going to go through this very quickly. If you take elementary particles, quanta, photons, electrons, and so on, you send them through two slits, and you look at a screen to see what happens. If you don't know which of the two slits the particle went through, then you get an interference pattern. And this, of course, works just as well if you're sending a single photon or single electron at one time. The mystery is that as soon as you do know, by any means, which of the two slits the particle goes through, then you get a pattern that looks like it's particles.
Boom. That is the basic experiment, okay? Back in 1801, they weren't sure if light was a particle or a wave. And that really goes back to matter, okay? Before Thomas Young in 1801, before he did his first double slit experiment, the going idea was everything's a particle, right? The sun sends energy, it hits me, I feel it, it can burn me, and emits some sort of photon. That's what we found with photons, okay? That was Einstein's big breakthrough. I dusted off my solid state physics book from the academy and I realized it's ridiculous. I don't think anyone actually understands it. The double slit experiment blew everyone's mind in 1801 when it was first initiated. It still does it, okay? This is over 200 years later. We still don't know what is really going on with this experiment. And I think once we determine this, once we figure out once we understand this experiment, I think we will have huge breakthroughs in many fields, many different fields. I think this is the new form of science, okay? Something is wrong with our model. Something is wrong with our understanding of the universe. And I think this could be the key, is actually figuring out this single experiment. You take an electron gun, anything that shoots light, okay? It could be a laser, right? This is a green laser, and you put it through a wall with two tiny slits in it. If you have a single slit, you will actually get a interference pattern like this, okay? And if you have a double slit, what you'll find is it's actually interfering. So we have constructive interference where it's bright and destructive interference where it isn't. And this is what makes waves unique, okay? So waves can be stacked on top of each other and they can subtract from each other. So think of it like energy, okay? Waves act like energy. They can be added to and subtracted so that we get interference patterns, right? Where they've been acted to together in constructive interference and they've been subtracted into destructive interference. Okay, that's what waves can do. Matter, we can't do that, okay? Matter cannot do that, right? So for us, you can't subtract and add something to me, right, in terms of energy, at least not that we know of. Look at this. If we shoot one electron through this double slit, this is what you're gonna see, okay? So here it comes. It looks like you're looking at water, right? But this is how light behaves. This is how light behaves. There's no light that should be hitting this part of the wall back here, right? Based on our understanding, if it was a particle, if it was moving through, right? If it was like little tiny bullets, it would just go through and then hit on the wall in a normal diffraction pattern, okay? But what we're seeing is light actually comes here, okay? So somehow, look at that. Light will hit on this wall. You start the light here, you shoot it, and light hits here. So effectively, the light went through the wall. The energy is going through the wall. At least that's what we see it as. Unless you observe it, unless you look at it. And it doesn't matter if we know now or if we know in the future. If we are ever going to know the path of this electron, then it will be a particle. It will act as a particle. It's us observing it. We affect the system. We affect the solution. How we even observe it, from many different ways.
Well, why do we see a particle? Why does observation make a difference? So this is sometimes called the von Neumann chain or the Heisenberg chain. Where is the cut made? When does quantum become classical?
This is basically the Heisenberg uncertainty principle, right? Is because you can't actually know where it is until you look. And once we look, then we know exactly where it is. But then it stops acting like a wave. Now it acts like a particle, and we affect it. We are able to affect how these things behave, either as a particle, which means normal matter that we're used to, or as a wave, which is like information passing through a substrate, just like information on your tapes, CDs, DVD players. We look at it and now it is a particle. But when does that happen? Where does that actual point take place? Is it when the detector detects it? Or is it when a human looks at the results? Well, you can test for all this stuff. And they found very, very interesting results that go against our normal understanding of how the world works, right? Normally when we look at something, we observe it, then we write the note down, right? We're observing a reality that already exists, a firm reality that doesn't change when we observe it. With this though, what we see is when we observe it, we affect it, we change it. It almost like it renders into particles. When we observe it, interact with it.
John von Neumann said that the measurement chain ends only when knowledge of the measurement is registered by what he called an extra-physical factor. In other words, you can't use another physical system to end the chain because it just becomes more quantum. So you need something extra-physical, by which he meant consciousness.
What he means is something outside of the system, right? If you're listening to music, you actually don't know where it's coming from, right? You can tell based on the quality, or you can hear the tape skipping, right? These are clues, if you will, into the base substrate, the substrate that the information is actually on. We moved a lot in the military, and each time my wife would carry this large suitcase of tapes. Maybe those are the only tapes left, right? That is information. But now I'm like, why don't you just stream it? But assuming a perfect reproduction, right? Assuming a good reproduction of that sound, you can't tell where it actually comes from. You don't actually know the substrate. So what von Neumann is saying here is that measurement chain, it ends only when knowledge of the measurement is registered by an extra-physical factor. So when it's written into the tape, essentially, something about the substrate, when that information is coded in, when it's rendered, then somehow it becomes measured and it behaves as a particle. But almost until that point, it's a wave, right? If we don't look, it's a wave.
And he wasn't alone in his opinion. Almost all of the founders of quantum mechanics said something like this in various ways, but go all the way back to Bohr and even Planck. They all said something like this, and this continues to the present day, as you know. This is today a minority opinion within physics, but nevertheless, it has a pretty prominent background.
I just want to highlight they still don't have a clue. I watched a recent interview with Penrose.
Theories of quantum mechanics may be missing the same element that the universal Turing machine is missing about consciousness.
Yes. Yeah, this is the view I held, is that you need a theory, and that what people call the reduction of the state or the collapse of the wave function, which you have to have, otherwise quantum mechanics doesn't relate to the world we see. To make it relate to the world we see, you've got to break the Schrödinger equation. Schrödinger himself was absolutely appalled by this idea, his own equation. I mean, that's why he introduced this famous Schrödinger's cat as a thought experiment. He's really saying, look, this is where my equation leads you into it. There's something wrong, something we haven't understood, which is basically fundamental.
Just sounds like they're not willing to accept a simple change to their model. If you think back to Copernicus, if you think back to Galileo, okay, the amount of math that had to be done to make the planets align based on a Earth-centered universe is ridiculous, right? That's why they couldn't do it. Essentially, if you try and math out everything by a system, you're not the center of the coordinates, it's going to be extremely, extremely complicated. And I think that we're seeing the same thing here in quantum, okay? Just the level of complexity of these equations is just ridiculous, okay? If you look through just to resolve two particles that move, just in one instance, takes an amazing amount of math. And now if you have two particles that actually interact, from my limited understanding, we can't even mathematically model it, okay? To do the math, we need Feynman diagrams, these ways to shortcut the actual math. That tells me that our model, the base assumptions that we're using are just incorrect. In the same vein, if you just move the center of the solar system to the sun, all of a sudden the math becomes much easier and much easier to work out.
When it comes to this particular problem, the measurement problem. So what we did in the laboratory is we built a double slit system, and fortunately it's a very simple type of a system. You have a laser, you have a filter, you have a double slit, and you have a camera that looks at the result. So the only new element in this experiment is that we ask people, in this case like a meditator, to keep the double slit in mind and to imagine in their mind's eye that they could see which of the two slits that the photon went through. This is, as far as we could tell, the only way of directly testing whether consciousness is actually collapsing the wave function.
So that's the test, right? They asked people to think about which way the particle went, okay, to act as a mental observer. And they believe that this is the only way to test for actual relationship, direct relationship between consciousness and physics, right? They're trying to find this relationship. I mean, it seems ridiculous. This should have no effect on the results, right?
So this is what the apparatus looks like. The tube sticking out of the long box there is the far end of the helium neon laser, and the double slit and the camera are inside the box, so it's a sealed system. You can't see it with your eye, you can only use your mind's eye. This is the camera. It's called a line camera. And this particular one is 3,000 pixels long in a line. And what the camera sees is an alternating band of light and dark.
So this is the interference pattern. If it's acting as a wave, this is what shows up as. So what they did for the experiment is you can use mathematical equations to determine intensity of this, okay? Intensity. And what you should see if there's no wave is you will just get a diffraction pattern or two lines, okay? So basically two lines, and I've seen in other experiments, they just get a normal, basic, it's just a mass of dots. What they measured for is decreasing intensity of these lines, meaning it acts less like a wave and more like a particle.
So the overall result of the pilot studies was this. You see again, overall, we got a pretty nice effect. Meditators did quite well. Non-meditators overall got actually close to chance. And we ran the same system, and this, by the way, was 250 20-minute sessions, 137 people, and we ran the same system again and again as controls, which are the white dots, and we don't see any artifacts within the hardware or software or analytics that would suggest that there's some kind of bias in the system.
Okay, normal people just thinking about it affected it. But if you were meditating, now they were showing extreme correlation, meaning it definitely worked. Statistically, we can prove, according to this experimental result, we can prove that it affected it. Okay, so the only thing I can think for mainstream science is that they just don't think the experiment was done correctly. That's all I can imagine.
So here's the result of the 50-session pre-planned experiment using the same analysis that we had used in the previous experiments. And this gave us a 5 sigma result. So for those of you who are not used to the term sigma, think of it in terms of z-score. It's the same thing, a standard normal deviate. So we got a 5 sigma result when people were observing, and when nobody was doing the observing, we got almost exactly chance.
That's amazing. I love that delivery. But so 5 sigma is 5 standard deviations.
If you keep in mind that a 5 sigma result was able to give CERN the Nobel Prize for finding the Higgs particle, which turned out not to be Higgs after all, well, we got a 5 sigma result too, but I haven't heard from the Nobel Prize Committee yet.
If that didn't blow your mind, enough. Here's the final part of the experiment, and this is mind-blowing here.
So we decided to put the entire thing on the internet, so we'd be sure that we could rigorously separate people by distance. So there's the double slit. This is sitting on a rack that has a bunch of servers on it. And we ran this for 3 solid years, calendar years 2012, 13, and 14, ended up with over 5,000 sessions done by human observers and 7,000 done by robot observers. And I'll explain what that means in a minute.
So they didn't believe the results, and they figured maybe the people in the room are affecting it, right? Maybe they just lean forward, or the heat, or there's some minute change that's affecting it, right? So they put it online. They had people log in from all over the world, think about this experiment that was running in South Africa in their lab, and then they tracked the results.
So this is the result of the sessions in 2012. There are 2,303 sessions done by the Linux system. These are the middle 20 fringes of the interference pattern, and it shows in terms of z-scores where it was. There's one or two of them that were around 3 sigma, but overall it was pretty close to chance. And this is what we got with human observers. So some, again, approached 5 sigma differences. That was 2,089 sessions by 689 people around the world. So what's nice here is they're able to look at yet another issue, which is, does distance matter? So this is the distribution of the effect sizes from where we were in California to the farthest that you can get from our laboratory, which is South Africa, which is 18,000 kilometers away. And so we did a linear regression. It turns out to be flat to 6 decimal places, but not null. It actually, that line looks like it points at 0, but it's below 0. That's why we ended up with a significant effect. So the observer effect is independent of distance.
Look at that. Oh my gosh. Observer effect is independent of distance. So just think about what these results mean. They mean that you can mentally affect something independent of distance away. So think about this. If you can think about something and affect its waveform, right? So let's say we have a double slit experiment. We put it on Mars. We put a little double slit experiment on Mars. You think about that little which way is it going on that double slit experiment? And you can affect the interference pattern, right? Someone at that experiment site could see, hey, it went down. Bill is thinking about this, if Bills are out there. In effect, you could do a 1 or a 0, right? You could do interference pattern or decreased interference pattern, or interference pattern or particle pattern. Now we have 2 states. We have a 0 state and a 1 state. We can do a 0 and a 1. We can now pass information. So that goes back to information is substrate independent, right? So we are passing information, but what is the substrate? Information's substrate independent, meaning it doesn't matter for the information. What substrate is it traveling on? But my question is, what is the substrate? And if you ask science, right, if we look into science, what is it now? Nothing. They say nothing is the substrate. In between molecules, nothing, right? Nothing. Out in interstellar space, nothing. Inside atoms, nothing. Effectively, everything is nothing. As far as you look, right? We're made up of atoms. 99.9% of atoms are made up of nothing. So we're effectively 99.9% nothing, right? Does this make sense? I argue not. I argue that there is something there, right? And they found that through recent experiments. Gravity waves propagate. Normal electromagnetic waves are propagating, right? We say through nothing, but that is because it is the substrate that we can't see. We can't see the substrate. So what is the substrate? They give an answer in this.
So what's the overall reaction to something like this? We're saying, would you look through the telescope? No. We don't want to. And the reason is this. So a lot of people have felt, and I've heard explicitly people saying, if this is true, we need to throw away the textbooks. So we can't throw away the textbooks because we know too much already. That is probably correct within each discipline in science. So what do we do with this? I'm going to present the world's fastest analysis of what's happening here. So reductive materialism is predicated on a model that looks something like this. Physics is at the bottom, chemistry, biology, psychology, consciousness is somewhere near the top. But consciousness doesn't mean anything. And from this perspective, the idea that mind and matter directly interact with each other in some way is forbidden.
Okay, if you can imagine psychology, what is psychology actually on? The substrate is on humans, right? Psychology, human mentality, human brain. Okay, that is the substrate of psychology. But what is psychology built on? Okay, it's built on actual human materials, right? Physical, biological materials. It's built on that. That's what psychology is written into our bodies. Biology is the substrate of psychology, okay? Psychology runs over biology. Same thing, biology is built up of little chemical bonds. You can't have biology without chemistry, without the chemical bonds that actually build everything up. And what builds the little chemical bonds is physics, okay? The laws of physics that we understand them. Problem is, where do you put consciousness in that? Okay, how does consciousness fit in? right? We can turn off consciousness. When you go to have surgery, general anesthesia shuts off your consciousness, without a doubt. You are not conscious at that point, and now you turn it back on. Before you were alive, you were not conscious, right? But now we are. How do we describe this? Isn't this strange, this consciousness thing? Where does it fit? Okay, and that's where they're trying to slam it in here. But it doesn't make sense because the information is on a different substrate. We cannot find what is the substrate of physics. What is the substrate of everything? And right now we say it's nothing. And I would say even nothing is something because it's an absence of something, right? But I think it's even more than that. I think nothing, what he shows here is what are we going to find there is from this experiment is that we're going to find the actual base of our physics, the substrate of physics, everything goes on is going to be consciousness.
Very difficult. Now, Stuart Hameroff has come up with an interesting model, and there are more and more models coming along that suggest there may be a way to stick within the existing scientific paradigm and solve this problem. But the other approach, of course, is to take exactly the same disciplinary structure, but just take consciousness and stick it down there. So it's a new metaphysical base on which we sit. From this perspective, just like in physics where you have electrons that go everywhere up in the pyramid, here we'd have consciousness that starts at the bottom and goes everywhere up.
And for me, this just makes it so much simpler. I think our math will be so much simpler because what we're trying to do is we are trying to take a model that doesn't make sense, that isn't a correct model of the universe, and we're trying to overlay it onto a square hole. We're taking a circular model and we're overlaying it over a square universe, and it's just not working, okay? And I think this experiment, which we've been trying to solve for the last 200 plus years, I think this is the key. If we can get here, I think this will show that it doesn't matter how small you go in physics, what you're going to end up with is consciousness, and it may be the substrate of everything that we see. What is this exciting for me is experiments. We can come up with different experiments to actually break through and figure out, is this the case? And how does it relate to UAPs, right? We've made no real breakthrough in UAPs, and we haven't really made any breakthrough really in this understanding of this quantum experiment from 1801. What do you guys think? Thanks for watching. I read all the comments best I can. Smash that like button if you did like this video, if it did blow your mind. It blows mine every time I look at all this stuff. So happy I get to be able to do this. Please subscribe to get notifications of my videos every Friday. And if you want to join the team, support the channel, go to patreon.com/Chris Slater. We have exciting stuff coming up. I want to make some actual experiments using NFT funds to figure some of these questions out. Super exciting. Thanks for being here. Thanks for being on the ride. Have a great week, guys. Peace.